In this short video, you'll learn about quality control tools used to manage project quality during project execution or implementation. First is a brief overview of controlling project quality, followed by an explanation of quality planning, quality assurance, and quality control. Quality control will then be the focus of this video, including an explanation of quality control methods. The term quality refers to a degree or grade of excellence. To set the scene, controlling quality in project management is the process of monitoring and recording the results of executing the quality activities to assess performance and recommending necessary changes. It measures the completeness, compliance, and fitness for use of a product or deliverable prior to acceptance and final delivery to the project sponsor or client. It's done by measuring all the steps, attributes, and variables used to verify conformance or compliance to the specifications stated during the planning stage. And this is defined from the client or the end user's perspective. Quality control should be performed throughout the project to formally demonstrate with reliable data that the sponsor and/or customer's acceptance criteria have been met. So quality control is very much about data and being evidence-based. However, controlling quality can also depend on the industry, and some industries are much stricter, where the cost of quality could be very high, for example, through loss of life or serious injury. So some examples here are health, transport, and pharmaceuticals, where quality control can be far stricter. In controlling quality, we're usually checking for the following: the performance and features of the product or deliverable, its reliability, its conformance, its durability, its serviceability, the aesthetics, and also perceptions. We'll now review the difference between quality planning, quality assurance, and quality control, as these are key quality management concepts. Quality planning is identifying which standards are relevant to the project and deciding how to satisfy them. For example, your project may need to comply with ISO standards. These are all articulated in a quality management plan. Quality assurance is evaluating the overall project performance to ensure the project will satisfy the relevant quality standards, those articulated in that quality management plan. The process is to ensure a product, service, or deliverable meets the performance requirements. So some examples here are having clear specifications and having defined standards, because it's very difficult to have good quality control if you don't have proper specifications and standards that you can measure to. Quality control is monitoring specific project results or the deliverable itself to ensure that they comply with the relevant quality standards, while also identifying ways to improve the overall quality. We'll now look a little bit more deeply into quality control. So this involves measurement and can result in the following. So first of all, we can eliminate or reduce rework. So it can eliminate waste if we have really good quality control. We can complete work in progress properly, and we can get that confirmation of acceptance from the project sponsor or the client. It also provides us with documented quality improvements and also process adjustments and improvements. So in the bottom corner, we can see a 5-star rating. And here's an example. When testing a product, service, or deliverable, we may gain some user feedback as a star rating. And we want our average star rating to be 4.5. That's a target that we've set. So we gather feedback from 20 end users who try our product or deliverable, and they give us an average rating of 3 out of 5. Well, this lets us know that we're falling below the targeted performance standard. Remember, we set it at 4.5. So we have some improvements to make in quality. We'll now look at some quality control techniques. So here we have a list of typical examples of quality control methods or techniques: histograms, pie charts, checklists, statistical sampling, benchmarking, experiments, having meetings to discuss quality, doing a quality audit, inspections, and using a lessons learned log, which is like a continuous improvement log. We can capture all the different lessons in quality and apply them to this project or to future projects. So while some of these on the list are quite well known, so conducting an inspection, we might use a checklist to ensure a deliverable meets the defined quality standards and specifications, or we could conduct a quality audit to assess the compliance of things on the project. Some of these are also not well known. So next we'll go through some of these other quality control techniques using some examples. So first we have a histogram or frequency grid. This is shown on the left-hand side. It's a simple bar chart showing dispersion and shape of statistical information. In this case, it's demographic information about age. On the right-hand side, we have a pie chart, which is a type of graph in which a circle is divided into sectors that each represent a proportion of the whole. In this instance, male-female. Again, it's demographic. So our example project is a website, and the project manager is checking who is viewing the current website to inform the design of the new website. This data is from Google Analytics. The project manager can then compare the performance of the website before and after the updates are made. So the histogram on the left shows the distribution of age groups who visit the website, and the target for this particular company are women aged between the age of 25 and 44. That is their target market. But we can see that most are currently in that target range and also spread quite widely across, all the way up to 65 plus. The pie chart shows us that almost 40% of visitors are actually male, whereas the target audience for this company is female. So with better targeting, the new website's pie chart should show closer to 100% female. So this data can help inform the quality outcomes of this project. Next is a cause and effect diagram. This is used to diagnose and solve a performance issue by narrowing down the possible causes of the main issue. And we start by identifying the effect, that's on the right. And then we use categories over on the left to uncover the possible causes. And this is often best done through brainstorming or gaining input from others on a project. So here we have an example of a renovation project, and there are wiring faults in the installation of the lights. The project manager uses some categories to find out the causes of the faults. So the categories shown here are equipment, process and people across the top, materials, environment, management down the bottom. So the project manager and the project team have identified some possible causes. So under equipment, it could be tools, the testing equipment, poor training, or maybe faulty equipment. Under materials, it could be issues with the wiring looms not meeting standards or perhaps being a faulty batch. Under process, perhaps the process was not followed correctly or perhaps it's incorrect. Under environment, maybe there's poor lighting and conditions or poor equipment that make the task too difficult to do and has therefore been a contributor to that wiring fault. Under people, perhaps the person is not trained correctly or not currently certified. And under management, perhaps the management did not identify the failure in the process. Here we have a control chart. This sets the upper and lower limits to determine a stable or predictable pattern of performance. So this technique is based on having a lot of data. So we start with the basic time series data. Then figure out the average, this line in the centre. Once we have the centre line, we can tell how much variation or deviation there is. So we make our regular measurements, and it might be something like, for a website, the output of the website designers each day, might be the lines of code they write or produce, Or it might be the number of website errors that are identified in their coding each day. So we gather that data. Or if it were a renovation project, it might be the number of injuries that workers sustain each day, or perhaps errors made during construction each day. Once we have this data and we plot it across time, then we can tell how far the output is deviating from that centre line. This gives us a standard deviation. That is a standard amount of variance from that average line. When we do this, we can also see a range of variation. And this helps us to figure out the upper and lower control limits. Ideally, 95% of our measurements should fall within 2 standard deviations from that centre line. If we get a data point or measurement that is outside of our control limits, like this one at the top, then we should investigate the root cause of that problem. And there are actually software tools that can create control charts from a data set for you. Next, we have benchmarking, and this is comparison with comparable projects or industry standards to identify best practice as a basis for measuring performance and generating ideas for improvement. So we have an example here. It's a website, and the project manager is reviewing a benchmarking report from Google Analytics based on industry performance. So the data on screen is based on the whole of the industry that the company is working within. It's not just their own company data. So this produces a heat map showing where this company has over and underperformance. And we can see here where some things are in green, showing they're doing quite well, but there's also a lot of red on this page. So this project manager can use this benchmark to look at what the standard is across the industry, and when they update that website, or as they're updating it and checking the Google Analytics, they'll hopefully see that there's a lot more green and not so much red. So it's a quality control technique. Lastly, we'll look at process flowcharts. So these are sequential displays of the steps showing their branching possibilities. So our example here, it's back to the website. The project team have come up with a process for logging into the e-commerce part of the website. We can see in red that they start up the top, the visitor enters the website, and the first decision point or check is whether the person has an account. If they don't have an account, they need to follow the sign-up flow. If they do have an account, they can log in and continue. So we're essentially just following the flow of arrows and the different decision points which are shown in this instance in yellow. So in this flowchart, you will notice different shaped boxes. These symbols and boxes have different meanings, and we can see some examples in the middle here in the table. However, there are many more that can be applied to a process, such as showing documents, databases, mergers, and delays. By clearly defining and agreeing on the process, the team can check for errors in each step of the process and also check that the overall process meets the user's requirements. For example, with a website, you don't want the user or visitor having to do lots and lots of clicks to find the information they need. You could check that through this process. To produce a flowchart, you can use different Microsoft tools. So Visio, Microsoft Word, PowerPoint, and Excel all have the capability to create flowcharts. And that's the end of this video. So you should now have a much better understanding of controlling project quality. You should understand what it's about, the differences between quality planning, quality control, and quality assurance, and know more about quality control methods.